Yes. All right. See you in a minute. Bye. He's on his way to the room.
Okay. Welcome everybody to our ABA Engineering Academy webinar that we hold each month, which is on the third Tuesday of each month, and we're glad to have you with us today. John, I see you're with us today. Normally you're on the road somewhere or some field working on a transmitter.
Yeah, well, luckily I'm in the office this week for a few days before I head to the Georgia Association of Broadcasters this weekend. So it's nice to be home for a change.
Oh yeah, quit living out of a suitcase.
Yeah, exactly.
What's going on in your world that we talk about? Anything important?
Well, I think the major thing we have to remind everybody about, of course, is Form 1, the ETRS for the FCC is due on October 3rd. And I think the majority of people I've talked to have already done their Form 1s. But if there's anybody on the list here that hadn't completed Form 1, you want to do that immediately because October 3rd is coming real fast. And as things seem to happen, there's always a concern right at the end that um, we the system will go down, and of course the commission doesn't give you a free pass if the system's down. And might mention too, Larry, you kind of spearheaded some of this last week. We all had issues with the National Weather Service. Um, it seemed that the update that they did, well, I don't know if it was National Weather Service. I think you mentioned that there was an issue with the internet service provider to all these sites that were converting over to fiber. But if you did not receive a required weekly test from the National Weather Service, you should this week on Wednesday. I know they've done a good bit of testing over the past few days, so I think most of the issues are straightened out. So those are the two main things. If any of you folks on the webinar deal with the public file, the quarterly issues programs are due at the close of third quarter, so that means those have to be filed on or before October 10th. And I certainly caution and warn everybody, don't wait until October the 10th to file it. I would file it as soon as I could uh, after the 30th of September because the commission does look at filing dates, and you don't want to get caught again with missing a date. The 10th of October happens to be on a Friday, so if you miss it, uh, it's going to be Monday before you can do anything about it. So those are some of the highlights that we've had. A couple of shows coming up in the next few weeks, just as I mentioned, Georgia, and then of course, Wisconsin's ongoing right now. And then the end of next week, which will be Thursday, is the Midwest Expo, which is in Columbus, Ohio. It's put on by the Ohio broadcasters, but it includes the states of Michigan, Indiana, Ohio, Pennsylvania, and Kentucky. And it also happens to be the National SBE convention at the same time and in the same place, all in conjunction with each other. So if you're an SBE member and you're thinking about going to the show, that would be an ideal um, place to enjoy a lot of exhibitors. I think there are going to be 50 plus exhibitors plus the convention itself. So I just got word from Jeff that he is booting up his computer in his room, so he should be joining us any minute as well, too, Larry.
Okay. You mentioned something about the issues and programs and making sure they get filed. We've actually we've actually heard from a lot of people, and you and I have talked about this. If you miss a filing date, you can't go back and move it to the right date, or even if you file it and put it in the wrong. file, be careful and don't move anything because once you send something to the online file, it's the computer dates and timestamps it. And if you try to move it out of the wrong folder into the right folder or change a date, it's going to change it for you to the current date and time. So that's really a problem. And John, I think you mentioned one day that if you want to if you do file it in the wrong folder and you want to try to get it where it's supposed to be, you can go in and copy it and then place it in the correct folder with a note explaining what you have done.
That is correct. You definitely don't want to move your original filing location. Just correct it and put a note there. And the same thing, I mean, um, I can't tell you what thought process the commission would have if you're a day or two late, but if you're normally filing on time every quarter, I'm sure that carries a good bit of weight. But if you have a record of filing late or not filing at all, that's definitely going to cause an issue with the commission, especially at renewal time, because at renewal time there is a statement, or at least there has been in the past years, where you certify that all documents have been placed in the public file in a timely manner. So you don't want to get into a situation with lack of candor.
That's correct. You can always file early. You just don't want to file late. So
That's correct.
I know that's the public file is not really a technical item per se, but I've always felt that it's really good for the engineer to know something, at least have a basic understanding of what the public file is and how it works. Because as a general rule, if anything happens in a broadcast facility, they'll always come and ask the engineer. It doesn't, I guess they figure he knows everything.
Yes, I think that happens. And of course, in a lot of market situations, uh, the engineering team or engineering individual does have responsibility for the online public file or a greater portion of it. So it's something you certainly want to be aware of because we don't want to get in a situation where the commission's coming after you because you didn't file a report in a timely manner as such. Might also mention that with the quarterly issues and programs, you should look very carefully at the content that you are publishing in the online file because there are a lot of rumors floating around that the commission is going to start looking much more seriously at the content of the online issues and programs report. And that means things like uh, they frown on PSAs, just running them indiscriminately, and no public affairs programming that would answer the actual issues that you have deemed important to your community. So that's something to keep in mind as you move forward as well too, because we only have a couple of years before the renewal cycle starts all over again.
Yeah, that's right. And the while there's while there is no actual form for the issues and programs list, there are actually 3 points that you need to make sure that you cover. One is what the crisis is, how you address that particular issue, and when you addressed it, the date and time that you issued it. So if you cover those two things, I know you've seen some funny reports during the inspections, and so have I. I ran across one the other day that actually normally I don't read the content uh, on all of them. I'll look at a few to see what they are. And one had on there, and the only thing they had in there was, we do a call-in show from 11 to 2 every day where people can voice their opinion, period. And that, I'm sure the commission wouldn't speak too highly of that one.
A very good example. I've even seen some that part of our programming for the community is we provide the best rock music. So I mean, it's there's a number of things that pop up there that would not be acceptable with the commission. So you certainly want to be sure that you are addressing the issues that you find important in your community, and most of those are things like education, politics. Could be conditions of highways. There are a number of things that affect each community differently, and the commission recommends any number of five to maybe 8 or 10 issues. And then, of course, you have to show how you've addressed those issues each quarter with specialized type programming.
I was looking to see if Jeff had joined us. I was looking through the list here. He is, I forget where he's in Wisconsin, I think.
He's in Wisconsin, so the last text I got from him was he was booting up his computer. Uh, so
Probably doing a Windows update.
yeah, that's probably what happened. So we should have him most any minute here.
One thing I will mention, sort of a shameless plug for the ABA. We have our radio engineering class coming up starting next Monday. We still have a few seats left. If you're interested in being a part of it, you can contact me and we'll get you all set up for it. It's held in Birmingham. Be the week of well, start next Monday, the 22nd through the 26th, I think it is, and then we have a television class coming up in November. The television class has really grown in attendance because we've added some new. There's some of the newer technology. We've gone into depth on it, and if you're involved in television, we're now covering the SMPTE 2110. For those of you who are not familiar with that, that's a replacement or an upgrade to IP operation of SDI, the serial digital interface. So we go through that entirely, and ATSC 3.0, which is, according to the committee, the ATSC committee is now, the last I saw, John, said that 76% of the households can receive an ATSC 3 signal.
That's pretty amazing. I did not realize it was that high because there are a lot of communities that, unfortunately, we live in one of them that do not have ATSE3 in their area. So I know that there is the big push with the NAB along with the FCC to have a complete conversion to ATSE3 sometime, I believe, in the next 2 to 3 years.
Yeah, that's
So
I think they said that the NAB has pushed the FCC to sunset ATSC 1 for, and I may be wrong on this, but I think it was the top 55 markets by 2028.
I believe that is correct. Is 2028 is the date that I remember. So
And then all the rest of the markets would be 2030, I think. Oh, I thought somebody had a comment. But that the rest of the markets would sunset in 2030. I will say this, from a technical standpoint, uh, if you take a look at it, ATSC3 has a lot of possibilities. It does a lot of things, and I saw just about a month ago an honest to goodness ATSC3 television, and it was set up at a station, and he could AB between 1 and 3. And it was astonishing to me. And obviously, you're doubling the number of pixels that you get, but the picture was really brilliant and detailed. So it does make a lot of difference. In addition to all the additional features that 3.0 offers. So we spent a lot of time upgrading our class. Uh, I want to thank at this point in time Skip Peasy, who has been a lot of help in putting this together. So we're covering that pretty heavily. Well, I continue to check here. Maybe he's having hotel internet problems, which is
yeah, it could be.
okay. One other thing I'll mention, John and I have been working on a document uh, that shows a station, especially a managerial, what is required, basically what is required to make sure that their facility is in compliance, and John and I updated some stuff on it yesterday. If anybody would like to have a copy of that to for your own use, or if stations you know of that don't have technical people that need some help, it covers all the basic things that a station needs to do to maintain compliance. John, you might comment on some of the things that we talked about.
Yeah, I'll be glad to. And just got an update from Jeff. He's booting up his Max Connect now because there's not enough bandwidth in his third world hotel that he's staying in to open his email. So,
Okay.
but yeah, Larry, it's and to all those that are online, uh, the document is quite a handy document. It gives an overview in very easy to understand terms of uh, things that you need to have on hand and that you should be doing on a weekly and quarterly basis at your broadcast facility. That would be things, for example, like uh, checking your station log each week, which includes all the pertinent EAS information, you know, the LP1s and 2s that have been received. And also, we talked a little bit about quarterly issues and programs and having a document book, which is very handy so that you know all the documents that you're required, such as your license, your renewal documents, STL licenses, ASR numbers. These are all things that we would ask for when we're doing an ABIP inspection, and the commission would ask for as well too. Pardon me, if they were doing a ABIP inspection or actual inspection as such.
Yeah, we've sort of it's sort of a ongoing project, but I think we've got it down to a point now where we'll be happy to supply anybody a copy of that. So just drop me an email and I'll be glad to send you a copy. And we just last night went back, or I went back in with some assistance from John, and we added actually some explanations, not just saying do this. We actually put in parentheses how you actually and why you need to do it this particular way. One in particular we were talking about was, and you'd be surprised how many station licenses or authorizations do not include the transmitter power output figure, both FM and especially television. Either in FM, it may be just blank, it's not there. And on in television, the license will actually have a statement as where the power transmitter power output should be listed. It says as necessary to achieve ERP. Well, if you walk into a station, if you're new there, how in the world are you going to know what you're supposed to adjust your transmitter to? So you really need to have a documentation. And John, I think you had some information about how you can obtain that.
Yes, the information is readily available on the FCC website, though you might have to do some digging for it in the LMS portion. What you would normally be looking for, it would be under applications, and it would be application for license, whether it be under television or radio, and it would be Form 302. If you dig down into the form, it's about halfway down. It just depends on whether it's radio or TV and the amount of documentation that goes along with it. But there is actually a place where you put in line length, any kind of filters, combiners that are put in place, line losses, and that's all calculated to determine what the actual TPO is. And that pretty much is on one particular page in Form 302. Again, it's easy to locate inside the form. And I would extract that page, make a copy of it, and place it in your notebook or post it on the wall if you still post documents on the wall. And that way you have that information there so there's no questions. We've had numerous stories of inspectors and including FCC people going into sites and there's no information posted and they started to do calculations and find out that the station was operating at the wrong power. Most of the time, it's not too much power, it's usually less power. And so, what you're trying to do is have that information so you know exactly where you stand and what your actual TPO is, whether it's for you or an inspector or somebody coming to fill in for you while you're out of town and they had a technical problem.
There's another way. That's a good way to get that information. One way that I found that you can do it, if you just go to the FCC website, which is fcc.gov, and click in the menus, click on LMS, which is a license. What does that stand for? License media systems or something. I
I
forgot.
can't remember. I think it's something similar to that.
But you can go in there and click on facility search and type the call letters in, and it will bring it up, all the information. And over on the right-hand side, you'll see all those files that John was talking about. And if you scroll down and you'll see license to cover, you can open that up and scroll down and you will see it will give you the ERP, the gain of the antenna, the loss in the transmission line, and all the way down to transmitter power output. So that's something that you need to do. And this is getting to be, and I don't know in your inspections, John, but I'm seeing more and more and more of licenses that don't have that, have TPO on there. And
Yes.
that's, I'm not sure how that gets through the actual commission, and it doesn't make it over to the license, but
Well, pretty much for all the TV licenses that I've seen, all the new ones, there is no TPO listed. Uh, Now, obviously, that information is compiled and put in that Form 302 when they apply for a license for the current transmitter operation. Some of those are hard to find because they go back for a number of years, and a lot of the consultants will provide a document that has that same information on it that becomes an attachment to that license, but that document's also very handy to have. The same was done. There were a number of firms that provided the same thing for FM because there was a period of time that they put no TPOs for FM stations as such. AM, we didn't really have that problem because with AM as such, there are a number of components that are all critical, such as common point or base current, and determining the power. And so that's part of the license, no matter what. But definitely wanting to be sure that everybody understands that that is available there, and you want to be sure that you have that information available. I believe Jeff is online now.
I think he
Uh,
is. I see him on the list here. Welcome, Jeff.
Well, thank you. So this is an example of needing backups to the backups to the backups. Uh, so the hotel Wi-Fi isn't powerful enough here to let Outlook even open your email invite. So I opened up my Max Connect. It can't find enough cell signal here to do anything. So I tried my work cell phone. It can't find enough cell signal. So I'm tethered off Bluetooth on my personal cell phone. So
Well, that's pretty good. Well, I'm glad you could make it and all. If you'll start staying at a little finer hotel instead of the
these
uh,
cheap Marriotts, I know.
yeah, well, I saw one day. As a matter of fact, my wife and I were traveling to Las Vegas one year. We actually drove out there one day, one year. We just decided we'd close up the house and go. We went through one city, and there was a hotel named This'll Do. That was the name of it. So stay away from those type. They don't have very good internet.
So there is a Best Western. I want to say it's in Clovis, New Mexico. It's called the Nursa Nickel Motel.
No,
And it
no
was
internet.
actually really nice, but yeah, sometimes
Yeah,
this is a big old hotel, but the emphasis is on old. It's starting to show its age. So
right, right.
you can't shove 1,000 people onto the same Wi-Fi connection.
All right. What we wanted to talk about with Jeff today is grounding. Of course, Jeff is well known for his theory and thoughts on grounding, but primarily I see a lot of people that don't really know how to handle and deal with copper strap. So, Jeff, if you'll spend a few minutes to talk about the reason for using copper strap instead of this regular wire, and then how do you actually go about connecting it to the equipment and making turns and soldering together, and just talk about copper straps in general.
Sure, and I mean there's a bunch of people who are really good at this that probably know more than me. But I said for everything I found, there's somebody that knows more than me. Um, I mean the big things that we look at when we're looking at grounding, and if I'm analyzing a site, it's always going to be the same. I want the grounds to be short and straight. The thing is that we're playing a current divider game. Okay, we've got the path through the equipment that we don't want the lightning to take, and we've got the path to earth or through the surge protector to the AC lines, depending on the situation, that we do want the lightning to take. And so we want the path, the preferred path, we need it to be the lower resistance possible of the two. Well, foot for foot, copper strap has got typically a much lower resistance than any comparable wire. I mean, a 2 gauge wire, as an example, has got 2.5 times the resistance per foot of a 32nd inch, 4 inch by 4 inch copper strap. So that means that if you ran a foot of wire and a foot of strap beside each other, 2.5 times more current is going to go through the strap. So, for grounding, that's our preference. That's the short answer in a nutshell. I mean, there's the obvious too. I like strap because I can tack it to the wall, or I can lay it flat on the floor and not have the trip hazard that I've got with a piece of wire. But the lower resistance is the big deal. When you're making the bonds, the connections, the big thing that we really speak to is that an exothermic connection beats a mechanical connection hand over fist every day of the week. If you fold the strap over and hammer it flat and drive a screw through it, eventually there's going to be some oxidation there, and it's going to become a resistor, at which point this whole current divider game applies again, and we've just increased the resistance of that ground. So, that's the ultimate goal. And I'm a big fan of silver soldering, Silphos. I don't like regular solder on strap if I can avoid it, because if you hit a lot of current with it, it'll get warm and it can melt, or it can get brittle over time, depending on the type of solder you use. So I do like brazing, but brazing copper strap requires a certain set of skills that I absolutely have not mastered. I can vaporize copper strap with the best of them. So definitely, I see Cole is laughing. So I think somebody else has burned a hole or two in a piece of strap. But yeah, you can brace copper strap. You can get CAD weld molds for it, but CAD weld molds for strap are pretty pricey. And they're rare. You don't find them in electrical supply stores for sure. They're used to dealing with cable. So for the most part, I go with brazing or silver soldering when I can. You can do silver solder with MAP gas. When you get into brazing, you almost need to move up to oxyacetylene, although I think you could do some brazing with MAP, depending what you're brazing to. So those are the big things. Let's see. I might have, actually, I know I have a slide deck. There's always a slide deck. Do you mind if I share one, Larry? I should ask that ahead of time.
Yeah, that'd be good.
Yeah, you mind?
No, I don't mind.
Sorry. All right. Let me see here. If I just back up a notch, I get ahead of myself.
While you're looking at, is there any, to use a common saying, does size matter?
So again, the resistance of copper strap is determined by the cross-sectional area times by the length. And so for, 2-inch strap will have double the resistance of a 4-inch strap because it's got half the cross-sectional area. So yeah, I mean, the size does matter to an extent. However, I mean, like if you're going to surge protector, unless you've scraped off a point in the surge protector and are clamping to the case with a mechanical connection that we already discussed, then you're going to be going to a bolt or a lug at some point anyway. So there's going to be a choke point. So it's definitely a point of diminishing returns. I mean, I probably wouldn't invest in 4-inch strap for a 4,000 watt or $4,000 translator transmitter, as an example. Um, but yeah, it's one of those situations where you definitely, you know, what do they say? You get what you pay for to an extent in almost every case. All right. While I'm rambling, I'm over here clicking on another screen. That's I think the coolest thing I've discovered is that these little portable monitors that USB monitors that you can grab. So let me click not the leave button, the share button. I've already messed up by being late enough now. And we will just go with that application. And rather than just going to the slide deck. So the ultimate goal is, like I said, short, straight runs. Am I sharing the screen that I think I'm
Yes.
sharing?
Yes, I got it.
Oh, yay. Uh, and I say use a tree like as an example. If you're in a tech center or a studio facility, then you might have a ground point for each room or each rack in the area, and then have those all tied together to a common point, sort of like what I've got sketched over to the right-hand side on this page. And that's fine. What you want to avoid is daisy chaining stuff, because then you can run the chance of creating current paths through equipment. And again, the goal is, so I'm going to skip by a bunch of these and hit what we typically see at a transmitter site. So the AC comes in one end and the RF goes out the other end. And of course, we hang all the stuff we don't want to blow up in between. And it's a wonderful system if you want to blow all the stuff up. But what we want is something that looks basically like this, where we use a surge protector. Now, here's something that a lot of people will argue with me about, and some may be right, some may be wrong, depends on the argument. But my belief and what we found is that the vast majority of, and take switch and supplies as an example, because they like to blow up with annoying regularity, whether they're in our box, whether they're in a satellite receiver, whether they're in a remote control unit. Um, as a rule, most failures on those occur from heat. The second biggest thing is surge energy. And what I believe, so you get a huge lightning strike coming down the tower, heading to Earth. Earth potential goes high at the base of the tower because Earth has a resistance per foot. And at that point, that energy's got to go somewhere to dissipate. And the power lines provide millions of miles of grounds and wires to dissipate on. So it looks for the fastest path to the power lines. And if it doesn't have a surge protector, like I've shown in this picture as a path, it's going to go through every switch and supply you've got. And some of them are going to fail faster than others, but some of them are going to fail. So having good solid grounding and surge protection in place, and I've got ferrite shown here. Of course, you called me Mr. Grounding. Somebody, Barry, Michigan, I see he's attending, said you could call me Mr. Ferrite, but the young kids wouldn't know what that meant. But yeah, the ferrites are that last resort. They'll add a little insurance. It's like the difference between 2-inch and 4-inch strap. Having strap at all is good, so that's your first big step. If you're still having some issues, maybe you move to a bigger strap. But if you don't have it laid out right, it isn't going to matter. And if you don't know what your ground resistance is, you don't know how much copper you need either. And I know that the Copper Institute has done a lot of work with this. I don't know if there's anybody from there on here, but they do a good discussion on site grounding as well. So the big things you want to look at is, it's like I say, it's a current divider game. So anything that increases your resistance, like using U-bolts to clamp a 6-gauge wire to the base of your tower and calling it a ground, not ideal. Twisting your AC entrance ground to the ground rod ground, again, not ideal. And of course, all my best pictures come from sites. Everybody's seen this one before, but I love to share it every time. Had a guy, he was just small little 1 kilowatt, and that's not him on the right. They're two separate pictures. But the left-hand picture, little 1 kilowatt station. The owner was the engineer, was the salesperson, was the receptionist. Little one-man shop, and really nice fella. But he put in his transmitter, an electrician buddy of his had said, if in a pinch, if you don't have a ground rod, a cold water pipe will do as a ground. And forgot to tell him that the cold water pipe ideally will not be PVC. It'll be something that'll actually conduct electricity. But anyway, the one on the right, that was, I mentioned earlier, exothermic connections. This guy had used those compression clamps, where you run your stranded 2-gauge copper wire into a clamp and it gets squeezed down against the ground rod. And I was walking by doing an inspection a few months later because he was so proud of all the grounding he'd done. And I grabbed that wire and pulled it right off the ground rod because the copper had compressed over time and become loose. So that's him brazing it together under the in the light of the, I think it was the Jeep, but yeah. So that's the kind of thing that you want to look for. Site assessment is probably more critical than the actual grounding technique used because so many sites have evolved over the years. Stuff gets added, grounds get moved, things get connected or disconnected, and stuff's left behind, and you get no idea what goes where. So a lot of times you just need to go through and say, well, is this a ground or is this not a ground? One example, if you have to cut the footer plate away from your building strut or building studs, then it's probably not a ground. This was the J-bolt meant to hold the building onto the concrete pad. So, it's sort of a ground because concrete conducts a little, but it wasn't ideal. So they ended up putting in a ground rod. On this particular site, their AC ground was this rod you can barely see here, just driven at about a 60-degree angle. So that got replaced with a proper 8-foot. It was a 2-foot rod, barely went below the gravel. But they put in a proper 8-foot rod driven straight, put a good ground at the antenna, connected the two together outside the building, and their failure rate went down a lot. So those are the kind of things that I look for. Like I said, short and straight. Definitely two things, Larry, and you mentioned straps. So let's hit strap for a bit. And I don't have a lot of pictures of that, and I wish I did. I probably do. I just have to find them. And that could take more time than you've got. But the copper strap, ideally, you don't want to make the current have to make a lot of U-turns. So if you fold a copper strap, number one, wherever you fold it over, solder the seams. And that makes it a more continuous run. It's not a loop-de-loop. Because if you hammer it flat again, you're going to get oxidation in that joint, and eventually it's going to just become a resistor. So there's a reason the resistor schematic symbol looks like a zigzag line. It's sort of like copper strap hammered flat with oxidation on it. Again, shorter is better. If I can make a run 10 feet instead of 20 feet, I've cut the resistance in half. So the current divider, one more time, the less the total resistance is, the less or the more current I can get through that. And I want that to happen. Now, on the stuff that I don't want the current to go through, I can make that line as long as I want to, but that's not the case. Like coaxes to equipment, for example. That's why on our AMs, when you get a J1000, if you buy our surge box, it comes with 50 feet of coax to connect between the transmitter and the surge box. And a little note that says, don't cut this coax. We want you to use the whole 50 feet, even if you only need 5, because we want the extra resistance in that line. So just as an example.
Yeah, here's something that I'm always asked. If you do a good job with you want to use copper strap and you do a good job, how does that copper strap, or what is the proper way to get that copper strap attached to the outside ground rod?
And that is a $1 billion question. Now, one of the guys I worked with a lot back in the day, Don Jones with our specialties in Texas, and I know John knows him. Don is he's still kicking. He's getting up there, but I've seen him wrap copper strap around a ground rod and actually braze it on there. I'm not sure I've got that skill set, but again, an exothermic connection, any way you can do it. I've seen other people put little slots in the strap and actually use like a hose clamp. And again, a mechanical connection's not ideal. So, it's a big challenge. I'm not sure I know the answer to that. I have seen tabs that you can braze onto copper straps, sort of like they put the tabs on the antenna to bolt to, but you always end up at some point with a mechanical connection.
So that I guess that was the question. If you want to do a good job, and you got all the copper strap, then somehow or another you got to get it attached to the outside to the ground. Now I've seen a lot of people, and I'd like to get your thoughts on this. A lot of people actually put in what's called a perimeter ground, where it goes
Uh-huh.
all the way around the building, and put ground rods maybe at the corner.
Yep.
Is that a acceptable way to do it?
It certainly doesn't hurt. Now, the caveat, and this comes into, and if there's any R56 fans in the room, plug your ears. So Motorola's R56 standard is basically the golden rule when it comes to grounding transmission facilities, and they emphasize halo grounds a lot, where you run the halo around the inside, and I'll get to the perimeter ground in a second too. Um, Halo grounds, I love them and hate them. Done right, they work wonderfully. Done wrong, they're a nightmare of ground loops and circulating currents. And 99 times out of 100, they're done wrong more than they're done right. So it's dangerous. That's why I like short and straight. Now, on the perimeter ground, a perimeter ground is a good way of, if we go back to my preferred site, if you had a perimeter ground there, it's a good way of establishing a low impedance path. And in an AM, what you can do is bring the radials up to it, run them over the building, and create a Faraday cage. So it kind of helps for RF shielding in the building. But it does give you a good low impedance path. The caveat is I would not run my perimeter ground into the building in more than one place. Okay, only one entry point to the building because I can't create a ground loop if I've only got one point. And that's the only thing that I would use as a caveat. So I would do the perimeter as a way to establish a good low impedance point, but to earth that is, but only one entry point to the building. Ideally, and that's that mythical perfect world. In this picture, I've got my coax coming out and my AC going in at the same point. In the real life, they happen at opposite ends of the building. So in a lot of cases, what I will do is, because the AC wiring tends to be smaller and higher inductance, higher resistance, I will tend to put surge protection and ground reference at the mains entrance point, and then have all of the equipment going to that point. So that's where I would run my primary ground in from my perimeter. But absolutely, I like the idea of a perimeter ground.
And would there be any advantage to using copper strap to tie the perimeter ground together, or is 2-aught just as well?
And this comes down to a cost versus benefit, and I mean, having it at all is going to put you way ahead of not having it, versus a couple of isolated ground rods. And going back up a couple of this site, this one would be a prime example. So they had, the tower was on the south side of the building with a ground rod. The coax, or the AC rather, came in on the northeast side of the building with a ground rod. The transmitter ground was on the northwest side of the building with a ground rod, and none of them were tied together. And so they had to rely on earth resistance between them. And in their case, they were blowing up, on average, he blew up half the value of the transmitter over 10 years in power supplies and amplifiers. So tying those three grounds together, putting in a surge protector as a bypass path, pretty much solve all his issues for a couple of grand. Now, whether he tied them together with strap or with cable at that point to me was totally irrelevant because I just needed them tied together. And whatever he had, whatever was cheapest. Again, strap will be a little bit better, but you're playing a matter of degree. What I tell people typically is the amount that you're going to invest in grounding and surge protection is directly proportional to the value of the asset you're protecting. Again, I'm not going to drop $250,000 to replace or to protect a $5,000 translator. I might drop $250,000 to replace or to protect a $250,000 HD system rather than spending $20,000 a year on repairing it. So it does vary. It's not a hard and fast answer.
The advantage that I see on a perimeter ground using maybe 2-aught or something like that is that you can bring your strap out and more easily attach the
wrap around and
strap
solder it
to
on.
the
Yep.
to the 2-aught than trying to get it onto the ground rod.
Yep, and I absolutely don't have an issue with that. The one caveat I would say is I would like to see the 2-aught CAD welded to the ground rods.
Oh yeah.
And I mean, you can get CAD weld molds on Amazon now. How awesome is this country? I mean, you can get ferrites on Amazon now. It's amazing. But yeah, you can go to Amazon.com and get a CAD weld mold to put a 2-inch or a 2-gauge wire onto, or a 2-aught wire even onto a 1/2-inch ground rod. Then they're under $100 a pop. I said,
they work
I
well.
made a joke.
Here's a yes or no question.
Yeah.
I saw a station the other day that I got to looking for a ground and I couldn't find it anywhere. I said, where's your ground for the transmitter going outside? He said, oh, it's in the concrete. He said, when they poured the foundation for the concrete, I actually put the ground strap in the grid work of the floor, and they poured the concrete. My thinking was, I don't know if that's good or bad.
So short term, it's just fine. And you'd need a chemical engineer to answer this with more intelligence than me, but my understanding is that concrete can be somewhat caustic, and I don't know if it would have any impact on the integrity of that strap over 20, 30, 40 years.
That was my thinking.
So, I mean, I'm a big fan of having anything that can deteriorate, and copper's a prime example, having that stuff where I can actually see it. So yeah, that's the kind of thing that I want to, I'd want to ask a structural engineer or somebody that knew the properties of concrete a lot better. But I would be a little cautious about that. If I wanted it buried, I'd probably be more inclined to run it through like a sewage drain pipe or, a piece of pipe and bury it that way. And that way you've got it so you could actually pull it out and replace it if it did disintegrate over time. Although if it's protected like that, it probably wouldn't.
Yeah, other than making the transmitter site look neat without the copper strap running across the floor, I worried a little bit about the chemical reaction of concrete and copper.
Right. Now I've run into a lot where they've done sealed concrete floors and then laid the strap down and then done like arborate or well, some of the old days asbestos, but put floor tile over top. And I mean, I don't have an issue with that. Worst case scenario, you rip out the floor tile, you can get to the grounds. But yeah, having it totally encased in the concrete, I think that would spook me a little because I mean I've spent enough time digging up grounds that were supposed to be grounds and weren't grounds. So yeah, having something buried like that where I can't get to it would bother me.
The single point of grounding that you discussed, where everything in the building is bonded together and then brought out to one point, is that same point the point that you would want to run the ground from the physical tower to, that same point?
Oh yes, yeah, So as of round about 2010, and your electrical ground has to go there too. And here's the other catch, depending, and I see folks here from all different parts of the country and parts of the world, because I see some from Canada and some from all over. Just looking at your attendee list. Um, Different states, for example, in the US follow different versions of the NEC, and some, Mississippi be a good example. At last time I checked, the Mississippi electrical code superseded the national electrical code. So an inspector in Mississippi will refer to Mississippi code, not NEC at all. Now, the reason I say that, because round about 2005, 2010, somewhere in there, Article 250 of the NEC, 250.4 specifically, was reworded to specify that electrical bond or ground and facility ground must be bonded together. And the reason I bring that up is because you'll still run into a few of the older electrical inspectors who will resist tying the AC ground to the tower ground. But at that point, you got to refer them to Article 250.4, the NEC. And again, it depends what version of the code or no code at all that you happen to follow in your location. So, be sure about that before you open your mouth. But yeah, technically they are supposed to be bonded together now.
So if you do a perimeter ground and
Mm-hmm.
you got everything bonded to that, everything coming out to a single point,
Uh-huh.
they'll if they've got like a pad mount transformer outside, can it be tied to the perimeter, or does it need to go over to that same point?
It could be tied to the perimeter. Absolutely could. Yeah. Like I said, I want a single point going into the building, ideally near where the electrical comes in. And I mean the mains panel in the building is going to be tied to that point anyway. But yeah, no, tying the pad to, say, the left end, let's get back down to my there. See, I'm glad I had these pictures. It makes it easier for me to point and shoot. But so if I had my pad over here grounded to my perimeter and then my tower grounded to my perimeter over here, that would be fine because there's still only one entrance point to the building.
Yeah,
So my equipment isn't at risk.
surge protectors and everything are all bonded together to that one point.
Correct. Like that.
Yeah, I had an electrician one time putting in a pad transformer, and he was adamant that he was going to put in his own ground rod at the pad,
And,
and I
and
kept
he can
after
certainly
him.
do that, but I am absolutely going to tie that ground rod to my facility ground like NEC requires.
He finally relucted and said, "Well, okay, I'll tie it in there." He said, "Give me the ground strap, ground cable. I'm not going to let you in my pad." I said, "I don't want to get you a pad transformer anyway." I said,
There's a lot of stuff I'm not qualified to play with, and that'd be one of them. Yep.
yeah, but I did stand there and make sure that he did tie it and just didn't lay down in the bottom of the transformer box."
Hmm. Yeah.
Going
So
forward,
that's
Yeah.
maintenance of these systems. What is a good procedure and I guess time wise to actually review your grounding over the years?
so a couple of
Visual?
things. And one of the things, this measuring ground resistance, I mean, we're coming off the driest summer we've had in recorded history in Nova Scotia. We've had exactly half an inch of rain in my neck of the woods in the past 4 months, in an area where we usually get 4 or 5 inches of rain every month. Um, this broke the record that was set previously last year, which broke the record that was set previously 2 years before that. Our neck of the woods is getting drier. And maybe in a couple of years we'll be getting wetter. Who knows? But being able to have an idea what your earth resistance is gives you an idea for that. Different areas. If you're in a more alkaline area where the ground is going to tend to dissolve a little faster, you would probably do an inspection more often as far as the actual ground system. As a rule, the ground system itself will let you know when you need to do some work on it because you're going to start to see failures creeping up. Then, like switching supplies. So I wrote an article for our Waves newsletter a couple of weeks ago, um, and mentioned that some of our older NV transmitters now are pushing almost 20 years old. So there's a lot of electrolytics that are starting to go. Fans are starting to go. You expect fans to fail in 10 to 20 years. So copper, same way, it's going to fail eventually. It's going to be determined by your own earth composition and how much copper you got down there. So yeah, I mean, you can dig it up if you want to, but usually I just watch failure rates and start to, cause and affect the whole deal.
John, do you have any questions or comments about what Jeff's been talking about?
Well, let me unmute myself. And no, I really don't. I know what Jeff has really expressed himself about on a couple of the situations on how to do the grounding around the building because I've been to some sites where they couldn't keep a telephone on the wall because lightning always ran into it and started looking. And just as Jeff described, the telephone came in on one side of the building and the AC power and the transmitter was grounded on the other side of the building. And of course, the path that the lightning always took happened to be the ground. One thing I will mention, Jeff, what about the use of chemical rods? I know we see that utilized in a number of situations, but I'm sure a lot of people are not familiar with it and how well chemical rods work in areas where grounds are not that good.
So some areas, and I see Wayne Pacino on here, and I know Wayne's over in Texas, and you get some pretty sandy soil there with a very high resistance. So in that case, a chem rod can help by you're creating an artificial ground field where you can't get down to the water system or down to the water table. So they help in that regard a little bit. Again, this is all a matter of degree. We're playing a current divider game. So I don't have anything bad to say about them. They do have a maintenance aspect to them. They do need to be recharged on occasion. You've got to keep the backfill material and the electrolytes that go in them. And I don't know the exact composition, some kind of sulfite, but yeah, so they can be useful in a mountaintop site. I don't know that they would do a lot of good in my neck of the woods. We deal with a lot of, I mean, you hit bedrock at about 5 to 10 feet or at the surface. So for us, we'll create an artificial ground well by basically blowing a hole in the granite and filling it full of water and carbon. And that's what you've got. And then just tie everything together. I've got one site on a mountaintop in Arkansas where they drilled a well 400 feet to get to the water table and just used ran the well casing down so that it was well into the water and then tabbed onto the well casing for the site ground. So, that's a $10,000 solution. So again, depends on what you're protecting. But sometimes I think a chem rod can be useful in an area with high ground resistance to kind of bring it down a little bit. But if I was in a situation where I had really, really, really bad ground resistance, I'd probably shoot for a well. And again, I'm not going to do that for a $5,000 translator, but for a $500,000 site, absolutely might.
Yeah, we've had to do that some around central South Carolina, which is a very
Mm-hmm.
sandy area, and a number of the TV sites had used wells with metal casing for grounding at their transmitter sites.
Yeah, and that comes back to the picture that I've got on the screen now. I mean, and I'm showing this fluke ground resistance tester. There are other ones out there, but knowing what your earth resistance is at your facility goes a long way toward knowing whether you should be looking at stuff like chem rods or wells or increasing. Because I mean, it maybe you're just fine. And if you can get into the water table, like if you're in Florida, it doesn't matter how sandy the soil is, because once you're 4 feet deep, you're into the water anyway.
Yeah, we actually did that here in Montgomery. We could not get a good ground where we were, and the water table was pretty high. So we had a well driller come out and he hit water down to like about 60 feet. And we
Hmm.
had some old Marmon clamp transmission lines. Some of you may remember that. Didn't have any bolts. It had that clamp around it. We had some left over from an old project. And we took that and welded the flanges together and dropped that down into the water and our master ground ties to that. And it just seemed to work really well for a number of
Yep.
years. So,
Yeah, if you can get into the water table, you are golden. And I mean that would be your primary ground point. For the most part, like I said, you got two choices: you go deep or you spread it out a lot. But yeah, other thing that I run into a lot, I don't have a picture, I don't think in this slide deck, but a lot of people like to put ground rods like every 4 or 5 feet, and it's a point of diminishing returns. A ground rod has an effective hemisphere of about a little over its actual buried depth. So if you drive a 10-foot ground rod like this, so 10 feet are underground, you could put your next rod 20 feet away, and that gives you the most efficient coverage because the two 10-foot rods are covering the entire area between them. So if you got an 8 by 8 building, one rod diagonally at two corners is going to cover that whole area. You don't really need to have like a rod at each corner and a rod halfway in between all the way around. I mean, you can do it if you want to, but it's extra investment for not a lot of return.
yeah, I read somewhere one time where if you put them too close together, there could be some interaction over the years that would somehow or another they would deteriorate faster. I don't remember what that involved, but if you put them too close together, you would have some sort of interaction between them.
Mm-hmm. Yeah, and Randy makes a good point about using 20 foot rigid and burying it and then tie them together. So again, same deal. At that point, you've got three 20-foot ground rods with nice diameter on them, and yeah, they'd be good for about a 40, 45 foot coverage area. So,
Well, I've never seen a 20-foot camera. No, that's a long one.
well, let's say he used a borer to bury rigid line.
Right, right.
So it's sort of what you were talking about with the well.
Sure, sure. Well, Jeff, I appreciate you taking time to be with us today, and
My
I,
pleasure. I'm sorry again for being late. You told me 10 and I translated that to noon Halifax time, and I'm not in Halifax at the moment. So
now you're up in that. Well, we're in the South, and we do things different in the South, so that's how
hey,
that
I-
works,
am
I
in
guess.
I'm in Wisconsin, so it's the same but with cheese.
Oh yeah. Well, appreciate you being with us, and let's see, you're in a convention, aren't you?
I am the Midwest Broadcasters Clinic. So what used to be the Wisconsin Broadcasters Clinic is tonight and tomorrow. And then I'll be heading to Atlanta to hang out with John George for GabCon for a day or two.
Oh man, you're hurting for punishment, aren't you?
Well, then next week I'll be back in Columbus, Ohio for the Midwest Broadcast Multimedia Technical Conference, and then up to Calgary for Wabi. So yeah, better than being bored.
Yeah, that's right. Well, I appreciate you being with us, and John, appreciate you
Certainly.
being with us. John is actually a sponsor of all our activities here. There's his calling card there. If you have any information you may need about broadcast equipment, contact him. There's his contact information there. And let's see, I've got information about the next. Oh, all these our uh, webinar today has been recorded and it'll be available probably by tomorrow up on our YouTube channel. There's the site. It's on YouTube, and you can either go to that particular site or just go in and search for ABA Engineering Academy. You'll see this one and all the different webinars that we've been doing since we began these things. Our next webinar will be on Tuesday, October 21st, so make a note in your calendar about that. And if you are not getting our Monday morning newsletter called Monday Morning Coffee and Technical Notes. Just drop me an email right there at lwilkins@al-va.com, and we'll be happy to add your list to there. Thank you, everybody, for joining us, and we'll see you in October.